phase diagram. All right, so the pressure here is in ATM, temperature is in Celsius. I want to make different points here. So you got to understand what you're trying to draw. And you got to understand that sometimes it's not going to be to scale. So what I want to do is just kind of look at different points. The highest value here is 72.8. Okay, I'm just kind of looking at different ones here. This is 5.1. This is 1. It's not to scale. It was just what was given. So I have 72, 5.1, and 1. Temperatures, again, think about what you're given. I have 31 degrees. I have negative 56.6. And I have negative 78.0. And don't worry about that if it's the scale or not. You just need to make sure that it's in the proper order. So then what you can do is you make these points. So it says it sublimes at negative 78. And maybe I'm not doing this great. We'll find out. 5.1 and negative 56 is the triple point. And the critical point is 72.8 and 31. Okay. What that means is a couple things. Is that if it sublimes on this bottom point right here, that is the barrier of the solid to liquid. So I'm not quite sure exactly how this is going to go, but it probably looks something like this. Okay? And then this value goes all the way up here and it stops. And unfortunately, we are actually missing a point. So we will have to add that data. So I apologize, you have to add something here. So let's just say it's this. The freezing point is at, I'm ad-libbing this, 10 ATMs and negative 36 degrees. So if I do that, let's put it right about here, negative 36, all right? And I'm going to make a value of 10 ATMs, which will go right about here. It's not to scale necessarily. So I make the point and it goes like that. Okay, so then what does that mean? From here, it goes up like this. So then what do I have? I have my solid and my liquid, and I have my gas. And what that probably means then that this would probably be the boiling point. And this would be the freezing point or the melting point, either one you want to call it, okay? So then I could ask some different questions. I could ask, is the solid or is the liquid more dense? Well, because of this shaded area, it's all above the liquid, and the fact that this line right here is a positive slope, I would say that the solid is more dense than the liquid. I could ask, when I'm at 1 ATM and negative 56 degrees, if I continue to lose energy, what process is occurring? Well, in this case, it's deposition. If for some reason I said that that was at 10 ATM and 31 degrees, what process would that be? So I'm up here now, and I start to lose temperature. Well, what's that? Going that direction? That's called condensation. So we could ask about all sorts of different directions and what process occurs in that phase diagram.